In this video we have a SIC position encoder talking Ethernet IP to a quantum PLC. And you can see here that we're looking at the structure. We're coming back. The position value is increasing at 1,000 revs per turn of the encoder. It's going up and down. What we need to do is we need to reference this to a predefined position. In order to do this, we actually need to use an instruction in an explicit message going out to the encoder. So with the quantum PLC, it's a little bit different than the M340 and M580. We need to use the MBP_MSTR instruction. And you can see as part of that instruction, we need to have an enable. The enable needs to be held high until it's done. So what we have here simply is we have a positive transition of the change position, and it's sealed in with the MSTR being active. So once we give it the pulse, it'll stay enabled until it's either has success or error. And as part of the setup of this, we need to set up a control buffer and a data buffer. These are arrays, and if we take a look at the data block here, the control we set up is an array of 10 for words, and for the data buffer we set up an array of 20 of words, which need to be located in the case of the quantum. So if we come back here, the setup of these arrays are predefined. We can go to the manual and we can see as part of the control array that it has some pretty descriptive setup for different type of explicit messages. In our case, we're going to do a set attribute single. So if we come in here, the setup for this, coming into the data buffer, it's very similar to the way we did it in the M340. We're going to have high word, low word set up for it. So the high word in this case for the first word of the data buffer is the pass size, and in this case it's always going to be 3. So we have this word plus 1, 2, 3. And this is going to be the position data we send down, the 2 words, because it's the position is a DINT, low word, high word. And then in the second word, we're going to set up the CIP message. The high byte is going to be the class assembly object. This information is received from the SIC website, and we know that that's a 23, and the class segment is a 20. So we stuff in 16 pound 2320. We know that it's instance 1, instance segment 24, so we stuff in a 0124 into the third word, and then we need to stuff in the attribute and attribute segment. Come in here, so 16 pound 1330. The last part of the data buffer is we need to put in the actual data. So it's 200 in this case, so that when we reset it, it'll send it back to position 200, being the low byte of the DINT position. On the control side, we come over here. We have a lot more setup over here. The first word of the control is going to be whether it's connected or unconnected. So unconnected is the way we send this. So we do a 16 pound 000E, 0E being the information that it's a CIP message. The second word is simply the buffer length of what the data buffer is. And in our case, we use 20 words setting up the buffer just as extra, so we put in 20 words for here. So in hex, that's 16 pound 14. And then the third register is when we have a response coming back from the transaction, where do you want that to be in the buffer? So in our case, we wanted it to start at word 10 of this data buffer coming back. So we just set it up as hex A, which is word 10. And the next one is indicating the slot where the NOC card is located, and in quantum it starts with slot 1, so it's 1, 2, 3, 4 where we have ours, so it's simply 16 pound 400. Going to the next 2 registers, it's the IP address. So the high byte is the octet to the left of the IP address, so C0 is 192, A8 is 168, coming down here 01 is 1, and then 10 is 16. So 192, 168, 116. We're communicating that's the IP address of the actual encoder itself. And then the last message here we have here is to tell how many bytes need to be transferred in the data buffer. So we have C, which is 12 in hex. So we have 2, 4, 6, 8, which is the request or the message, and then we have 10, 12, which is actually the data being sent out for the position as part of that. So if we come into animation mode, and we come over to here and we basically initiate the EIP Encoder 1, set home. Right now I can see my encoder moving up and down. If I set this to 1, it should preset to the 200 as we set it. Thank you.